Hello Lightning Leaders and welcome to another math video. I've been going through the scores on Zearn and I found another hotspot of things that I wanted to talk about. We had a chat in our Zoom the other day about how the wording in Zearn can be just really weird. So I want to put another video together to hopefully clear up some of your confusion, and maybe it'll make a little bit more sense once you hear it and see it from me. Now, the first thing I want to talk about is subtracting fractions. But before I go there, I just want to back up just a slight little bit and talk about making fractions with equal denominators. There's a whole bunch of strategies we talked about, but there's really one that I want to focus on the most. And that is, and I'm going to show you it now once I come up with some random fractions here to compare. Let's see. How about we do 3/4 and I don't know, 5/8. I want to know which fraction is bigger or smaller. Well, there's something I can do here to make my bottom number the same. Remember, I'm trying to make that denominator, that bottom number, the same, because then I have the same unit. It goes back to that argument when we were doing measurement. You can't compare centimeters and inches. They're not the same thing. Fourths and eighths are different units. They're different things. So we need to somehow make them the same thing before we can compare them or combine them or do whatever we're going to do to them. So I have to think, is there a way that I can make this 4 into an 8? And yes, there actually is. If I multiply my 4 by 2, that's going to equal an 8. And our rule with fractions is whatever I do to one part of it, I have to do to the other. Whatever I do to the top, I have to do to the bottom. So since I multiplied the bottom by 2, I have to multiply the top by 2. 3 times 2 is 6. So now I know that 3/4 and 6/8 are the same thing. But now, since I have eighths on the bottom of both of my fractions, I now have the same unit, so I can compare them. Now I just have to look at their top numbers. 6 is bigger than 5. 6/8 is bigger than 5/8. 6 centimeters is bigger than 5 centimeters. What we're doing here is we're just using a different unit type and to compare these numbers. Now, what I'm going to do here is I'm going to do another example, but this time our numbers aren't going to be so nice. There isn't going to be a way to make one number into the other number. I want to compare 2/3 and 3/7. Now, there's nothing I can multiply 3 by to equal 7. And I can't divide 7 by 3, or divide 7 by something to equal 3, so I got to do some other work here. Now, you could do some crazy mental math here and try to figure out something you're going to learn in middle school, which is called the least common factor. Or no, the least common multiple. Greatest common factor, least common multiple. You can try to find their least common multiple, but that's a little above our grade level here. So what we're going to do is something we're going to take the numbers that are right there in front of us, and we're going to make some fractions that have the same exact denominator, the same exact unit. Watch what happens here. 2/3. I can multiply this fraction by the opposite denominator, the denominator from the other fraction. Watch this. I can multiply this fraction by 7. Whatever I do to the top, I have to do to the bottom. And now I have 14, not over 12. It's been a while since I've done a math lesson here. Over 21. So now I have 21st as my unit. But I still need to change my 3/7. Now, we can do the same thing. If we multiply this fraction by the denominator on the other side, which is a 3, look at that. I now have 21sts as my denominator, so I can compare these fractions now. 14 or 9. 14 is the bigger number, which means 2/3 is the bigger fraction. The easiest way to compare fractions when their denominators, their bottom number, is not the same unit, all you have to do is multiply each fraction by the opposite bottom number, the opposite denominator, and you're always going to end up with the same unit on the bottom so that you can compare your fractions. I wanted to do a quick little recap of that before we jump into the subtraction thing, because in 4th grade they're super nice and we don't have to convert before we add or subtract. They're just giving us all like units so we can just focus on the math. We don't have to do multiple steps here. So I'm going to erase this and I'm going to jump into the subtraction lesson. Now, what was tricky about this subtraction lesson was we weren't doing something like this. We weren't doing something super nice like 3/4 minus 1/4 equals 2/4. We weren't doing something nice and simple like that. They were giving us something like this. 1 minus 2/3. This is a whole number. This is a fraction. We don't have a 3 in our denominator over here. We don't even have a denominator over here. So we got to do some work here. Now, we've been talking since 3rd grade about how to turn whole numbers into fractions. I'm going to show you something else here, and maybe this will help it click in your mind. Believe it or not, every single whole number is a fraction. Every single one is a fraction. All you have to do to make a whole number into a fraction is to put it over 1. So what I'm going to do here is I'm going to rewrite this so that I have a fraction here. So my whole number 1, all I have to do is put it over the number 1. And now I have a fraction. So they want me to do the number 1 minus 2/3. Well, look at my bottom numbers. They're not the same. I can't subtract them. So I need to make sure that this fraction over here has a 3 on the bottom. Well, to do that, I can multiply the top and the bottom by 3. So now I have 3 over 3, which is something we've talked about for a while now. One whole thing equals the same number on the top and the bottom. If I were to draw my tape diagram, right, this whole thing is 1. But if I wanted to make it into thirds, there it is. 1/3, 2/3, 3/3 makes up one complete thing. And this is where it comes from, right here. The number 1, one complete thing, one whole marker, right? One complete thing. If we broke it up into pieces, however many pieces we had, we would need that many to complete it, to put it back together. So our rule here, where we could put the number 1 underneath any whole number to make it a fraction, then we can just do our converting strategy so that we have the same number, the same unit, and now we can do some subtraction. 3 minus 2. If I rewrite this with our new fraction now, 3 minus 2 is 1, and this is our unit. It doesn't change. Think of it like when we did something like this. 3 centimeters minus 2 centimeters equaled 1 centimeter. 3 minus 2 equals 1. 3 minus 2 equals 1. The unit came along for the ride. It didn't go anywhere. 3 centimeters minus 2 centimeters equals 1 centimeter. 3/3 minus 2/3 equals 1/3. I'm going to turn up the heat a little bit with this next question here. And I'm going to use the tape diagram again. And then in my final example, I'm going to just do numbers. I'm not going to use a tape diagram. So this next example I have is the whole number 3 minus 1/4. I want to know what this equals. Well, I'm going to start by putting this into a tape diagram. Let's see here. I have 3 whole pieces. 1 whole piece, 2 whole pieces, 3 whole pieces. Right? This tape diagram is showing me that each box is worth 1, and I have 3 of them. Now, instead of taking 1 whole box away, we're only taking 1/4 of a box away. Well, I don't have any fourths in here. So what I'm going to do is I'm going to change one of my boxes into fourths. You see that? Now this box has been split into 4 pieces. 1/4, 2/4, 3/4, 4/4. And I'm going to take one of those fourths away. So let's see what I have left. I have 2 whole things, and then I have 1/4, 2/4, 3/4 left. So now I know that the whole number 3 minus 1/4 equals 2 3/4. I'm going to show this to you now doing that method we used with the last one, where I'm going to take this fraction, or take this number, turn it into a fraction, and do the subtraction. So I told you that any whole number can be put over 1 and it becomes a fraction. Now, if I want to do some subtraction, I need to make sure that my bottom numbers are the same, because I need to make sure I have the same unit. This is wholes, this is fourths. They're not the same. This is meters, this is inches. I can't subtract them. So I need to make some changes. But we already know how to do that. I can turn this 1 into a 4 by multiplying it. Multiply the top and the bottom. So now I know that 3 whole things turned into fourths, converting its unit, changing its unit from 3 wholes to fourths, means that now I have 12 fourths. There are going to, if I were to divide all of these up into fourths, I would be able to find 12 pieces inside of it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 fourths. Now that I have that 12 fourths, I can subtract. And my answer is 11 fourths. Now, this method has a lot more work to do, because now that we have this improper fraction, we would have to turn it into a mixed number, which is a video that I have already done. And if you're having trouble with it, I hope you watched it. If we were to convert this mixed number, or this improper fraction, into a mixed number, I can take out 2 whole pieces, because 4, 8 is as close as I can get to 11 without going over. And then I would have 3 left. So once again, make a little separation there. Once again, I have 2 3/4. I'm going to do one more where I keep my subtraction as a mixed number. Now, this is a strategy that will work because it shows you where this whole number is coming from. Where are we getting our answer from? We need to make sure that we have the same units, because we don't have the same units here. I really liked this picture because I never thought of showing it this way. And this picture actually really helped me understand it a little better. Even though I'm the teacher, I'm still learning new things every single time I teach these lessons. And that's what I love about learning, especially math. All right, we're going to try one more here. 9 minus 5/12. Now, instead of turning this 9 whole things into 12ths. Well, I need to take a drink here. My throat's getting sore. Instead of turning this into 12ths, we're going to do something a little different. I'm only going to take away one whole out of here, and here's why. I don't need all of the whole numbers. I don't need them all, because I know that 5/12 is less than 1, because the number on the top, the numerator, is smaller than the number on the bottom, the denominator. Because of that, I know that this fraction is less than 1. So I only need 1 to take away from. So I'm going to break my 9 into 8 and 1. And then I'm going to change this 1. I told you that you can take any whole number and put it over 1, and now you have a fraction. If I want to change this fraction so that it has the same unit on the bottom, I can multiply by 12, and now I have 12 over 12. The number on the top is the same as the number on the bottom. I still have one whole thing. So now with these new numbers, if I were to rewrite my number sentence, I have something that looks like this. 8 and 12/12 minus 5/12. Now I can just do regular subtraction. If I were to do my whole numbers first, 8 minus, there isn't a whole number over here, so my 8's just going to come along for the ride. Then I can do 12 minus 5, and I can do that because my units are the same. That 12, that's my unit, it's just going to come along. It's not going anywhere. 12 minus 5 is 7. So now I know that 9 minus 5/12 equals 8 and 7/12. I hope that some of these strategies that I talked about, the work I did, the way I laid it out, I hope that helped clear up some of the confusion from Zearn. I'm finding that some of the questions are worded weird, some of the videos are worded weird, and that's one of the struggles with this whole thing, is Zearn wasn't designed to be an instruction. It was designed to be something that students do after their lesson. So Zearn was supposed to be something you do after you get this lesson from me. And that way you can take what you've learned and you'd be able to piece together what Zearn is talking about. But since we're just going right from Zearn, there's going to be some missing pieces. So I hope that this lesson helped connect some of those missing pieces and fill in those blanks and helped you understand this a little better. I'm going to stop the video here, and I'm going to make another video about the multiplication lessons that are at the very end of Module 5. I'll see you guys then.